Lesson 5, Transformation Golf with Dilations, Dilations and Similarity. In this lesson, we'll show the two figures are similar by applying a sequence of transformations. All right, let's take a few notes here. We're on page 80 in your workbook, and we're showing that two figures are similar. Show that two figures are similar. Oops, there's an I. By applying a sequence of transformations. By applying a sequence of transformations. And I just want to remind you, at this point, we've talked about 4 transformations. 3 of them were the rigid transformations. I'm going to write those in black. We can translate, we can reflect, we can rotate, and now, big finish, we can dilate. We can make figures bigger or smaller. So those are the transformations I'm talking about that we're going to be using to fit one figure right on top of another. And that way we can show that two figures are similar. All right, so two figures are similar if one can be transformed into the other with a sequence of these translations, rotations, reflections, and dilations. And there might be all kinds of ways we can do it. There's lots of different sequences that'll work. We just need to describe one of them to show that the two figures are similar. So what we're going to do in these notes is show that triangle ABC is similar to triangle DEF. And we're just going to do what we can to fit that yellow triangle right on top of this pink one. Now, they've given us a boost here. We've got the same two triangles down here, but they've shown some intermediate steps that transforms one figure to the other. So I'm just going to give you my starting point and my ending point here with these yellow and pink triangles. And then talk about the transformations that'll get us there. So we're starting at triangle ABC. And one way that we can fit this yellow triangle on top of this pink triangle is to begin with reflecting this figure across line F here. So we're just flipping it around. Just jot down that we're reflecting across line F. So that gets us a little closer. We've got it kind of oriented the right way now, or at least kind of facing the same way. So we flipped it over line F. That's step 1. And now we're going to take this figure and imagine that this is on patty paper, and we're just going to rotate it right up until it fits on top of this little triangle. Okay. So let me see if I can highlight a little bit so that you can see what the angle would be. So DC is getting rotated to right here. We're swinging this side until it corresponds with that one. And maybe you can see that that looks like it's about 90 degrees. So we're going to rotate 90 degrees in this direction around point D. Remember, there's 3 things that we need to include if we are describing a rotation. The first thing we need to describe is the degrees. Looks like 90 degrees. The second thing we need to describe is the direction. We're going counterclockwise. And the third thing we need to describe is that center of dilation around point D. All right, so we've flipped our original triangle over. We've swung it up into position here, so now it looks like this little pink part of the triangle. And then the last thing we need to do is just make that little triangle bigger. So we're going to dilate to finish up here. And since this is our last step, I'm going to say this is pink. And in this little triangle and this big triangle, they overlap here at point D. And if you have overlapping figures, that's usually going to be your center of dilation. So center D. And a scale factor, well, I suppose I can measure, but just eyeballing it, it looks like if I'm looking at this little triangle, It has a length of about 3 for the little side here. And then if I want to measure this big triangle, I feel like, nope, I didn't measure that right at all. So looks like about 28 millimeters. And if I double that, I get this whole length of the big long pink triangle. The long part is twice as long as the short part. Scale factor of 2. Whew. So we just had a sequence of transformations. We had a reflection, a rotation, and a dilation that moved this yellow figure onto the pink one. And it can be a little overwhelming wondering where to start. And if you're looking for some kind of pattern, my suggestion is to start by using the rigid transformations to get a corresponding vertex to line up. So we got A to fit on top of D. Use rigid transformations. That's the translations, rotations, and reflections. The ones that don't change the shape. Use rigid transformations to get a corresponding vertex aligned. Let's say a line. Line, a corresponding vertex. Like A and D here. And then dilate it. Then dilate whatever vertex you lined up, make that your center of dilation. Dilate with that overlapping vertex as the center of dilation. You don't have to do it this way. There's an infinite number of ways that you can go. But if you're looking for some pattern that you can follow, start by just fitting one figure on top of the other with an overlapping point, and then dilate from there. So that's how we know things are similar. We can show that things are similar if we can apply a sequence of transformations that fits one right on top of the other. Good luck with your descriptions tonight.